In this video, I will explain you the series associated with de-excitation, that is coming from an excited state to ground state. So we know that when it comes from a higher energy level to lower energy level, a photon is emitted. And what is the energy of the photon? H nu. That is equal to change in energy. Initial energy is higher, right? This is the excited state. This one is higher than compared to the place where it is going to finally reach back. So initial energy minus final energy. Now how we will get the value of initial energy? We will substitute the equation which we know. Minus 13.6 into z square divided by n square, these many electron volts initial. So this is n initial minus of 15.6 into z square divided by n square, these many electron volts. So that will become, so this one is initial energy, this one is final energy. Now take the common term out. Minus 13.6 z square is a common term into, so minus, if I am taking out, this will become 1 by n1 square minus 1 by n2 square. So from here minus 13 z square I am taking, so I have only 1 by n1 square remaining. From here I am taking minus 13, so the minus will be there and 1 by n2 square will be there. So this is equal to h nu. What is that? hc by lambda. Now 1 by lambda is equal to, because we need the value of lambda, right? So 1 by lambda, that is wavelength associated with a photon. That is the radiation here in this case. That is equal to minus 13.6 z square divided by hc into 1 by n1 square minus 1 by n2 square. So in the school, they might have taught in this way, 1 by n2 square minus 1 by n1 square. But it is important in the way when we are defining n1 and n2. In school, if they have told n2 square minus n1 square, then n2 represents your excited state. That is from where it is coming. n1 represents to where it is going. As per my equation, n1 represents the initial position, 1 represents the initial from where it is coming, and n2 represents from where it is going. Or if you have any confusion, just think as per logic. From initially the energy will be higher. Let's say from 3 to 1 if it is going, higher energy to lower energy. Okay. So n1 is associated with higher energy, n2 is associated with lower energy. That is from where it is coming to where it is going. Now minus 13.6 divided by hc is another constant. This is taken as Rydberg constant. Minus 13.6 divided by r is equal, hc is equal to Rydberg constant. So I will change the equation to minus Rydberg constant into z square 1 by n1 square minus 1 by n2 square 1 by lambda. Now you can get the value of lambda. In the question they will be providing you what is n1, from where it is coming, what is n2, to where it is going, it will be provided. And Rydberg constant, it will be provided in the question. If you don't know, you can substitute in this value. 13.6 divided by Planck's constant, you know, C, you know, you can substitute, you will get the value. So this will be the wavelength associated with the photon while it de-excites. Now, there are different possibilities of de-excitation. First possibility is to the ground state, n is equal to 1. Electrons will come from n is equal to 2, from 3, from 4, from 5, from 6. These are de-excitation, and from others, 7 also, and others. From any excited state, if it is coming to n is equal to 1, this is called as Lyman series. N is equal to 1 from any value. Okay, so what is n final? N final will be, here in this case, n2 will be 1. So we have a negative sign here, right? We will take it inside. So when I am multiplying this will reverse the order. So 1 by lambda is equal to Rydberg constant into z square into 1 by n2 square minus 1 by n1 square. where N2 is the final orbit, N1 is the initial orbit. So with Lyman series, what is the value of N2? The value is 1. Now make a note of this. I am going to start this. From now we are only going to use this equation. With Lyman series, 1 by lambda is equal to R into Z square. What is N2? N2 is 1. So 1 by 1 square minus 1 by N1 can be anything. It can be from N1 is equal to 2, 3, 4. Any excited level. It cannot be anything, any excited level. So with respect to one, excited levels are 2, 3, 4 and 5. Now next series, it is coming down to 2 from higher energy level. This one. What is this series called as? Balmer series. So what will be the equation? This is Lyman series. Now with Balmer series, 1 by lambda of Balmer is equal to Rg square into 1 by, to where it is coming? 2 square, that is 4, and N initial. What should be the value of initial? Any value with respect to 2, it should be an excited state. So to 2 it is coming. So N value should be 3, 4, 5 and 6. It can be anything, 7, 8, 9, like that. Now next one is Lyman, Balmer, Paxton. That is to N is equal to 3 from 4, 5, 6 in this way. So I am only marking 3 because I have 3 more series. What is this thing? This is Paxton series. What should be the equation here? 1 by lambda Paxton is equal to Rg square 1 by, this one will be, N2 will be 3, 1 by 3 square, 9 minus 1 by initial. Initial square. Now similarly to N is equal to 4 when it is coming, then these are called as bracket. So Lyman, Balmer, Paxton, bracket. Then we have to N is equal to 5. After bracket we have Fund series. Then after Fund we have Humphrey series. Lyman, Balmer, Paxton, bracket, Fund and Humphrey. N is equal to 1, N is equal to 2, N is equal to 3, N is equal to 4, N is equal to 5, N is equal to 6. This will be the order. So 1 by Lyman, Balmer, Paxton, bracket series, Rg square, 1 by 4 square will be 16 initial. So here N initial can be 4, 5, 6, 7. So N is equal to 3 it is coming, right? From 4 it is coming to 3. Now here N initial should be 5, 6, 7. Right. So other series you can take down the values from your NCERT textbook. Now so these are the energy differences. These are the photon emitted. Now these emitted photons, when you are checking with the electromagnetic spectra, you will see that this radiation comes in ultraviolet region. Balmer series will come in visible spectra. We can see Balmer series spectrum. This is infrared. This one is also infrared region. So nothing but, see, we have different wavelengths here, right? Here from 2 to 1, one wavelength, 3 to 1, another wavelength, 4 to 1, another wavelength. So these wavelengths will be associated with UV spectra. Now here 3 to 2, 4 to 2, 5 to 2, 6 to 2. That will be associated with visible spectra. That's all. That is the difference. Now in the question they will say that what is the wavelength associated with third series of Balmer spectra. Now this one is the first series. What is the first series? From 3 to 2. Second series is from 4 to 2. Third series is from 5 to 2. So first series 1 to 2. Second series, first series 2 to 1, 3 to 1, 4 to 1, 5 to 1, 6 to 1, 7 to 1. first series, second series, third series, fourth series, fifth series, sixth series. If they are saying second series from passion means to n is equal to 3. So first one is 4 to 3 is first series. Second series is 5 to 3. So you have to keep 5 in this equation as initial and 3 as the final and get the value. You will be getting the wavelength associated with that. So learn this. This is very, very important. That's all. Thank you.